Hello and welcome back to the Age of Gaming. In the next few videos I plan on going over some of the mini programs and even a couple of the full-featured programs that you will find here in the first book of KIM. The mini programs are just that, very small assembly language programs with no more than 5 to 8 opcodes or commands in total. These programs are not designed to help you learn how to program in assembly language as much as they are meant to help you learn some of the detailed features of your KIM-1 and how to use them, like how to set up the necessary interrupt vectors so that some of those features will work properly, or how to single step through a program to check it out, and how to view or edit the contents of various system registers and memory address locations, and how to jump right back into a program where you left off. So let's get started with the first mini program called Mini Program A. The first thing they want you to learn is how to set up the NMI and IRQ vectors so that the ST stop key and the SST single step switch will work properly, as well as the BRK or break command. Just so you know, these special memory addresses or vector locations are not located in the system RAM. They are actually found in the 6530 Riot chip's memory. Riot stands for ROM RAM I/O timer. So basically it's like an Intel 8051 microcontroller. It has everything built into a single chip. You can see those memory addresses displayed here on the memory map, as well as special memory addresses displayed on the left. So let's go ahead and load those special memory addresses with the correct vectored addresses. First, let's turn the KIM-1 on and press reset. Next, we are going into AD or address mode and selecting address 17FA. Which is the low order byte of the NMI non-maskable interrupt. Then we're going to push DA key to enter data mode. We will enter 00 at 17FA. And press the plus key to advance to the next address, 17FB, where we will enter the data 1C. 1C00 is the first ROM address of the 6530-02 RAID chip, where the save machine routine is started. Then we will advance past the next two memory locations, 17FC and 17FD, which are the reset vector locations. And load 1C00 into memory locations 17FE and 17FF, which is the IRQ vectored memory locations. Okay, now we have loaded the correct vectored memory locations. We can start looking at and loading the mini program A into our KIM-1. This program is a very simple program that will exchange the data from two different memory locations, specifically memory location 0010 and 0011. So let's go ahead and start by looking at these two memory locations and entering our own data values into those locations. Okay, let's start by pressing AD again and going back into address mode and selecting address 0010. Now let's change the value by going back into data mode by pressing DA again and enter the value 00. Then hit the plus key to advance to the next memory location. As we are already still in data mode, we can simply enter the new value that we want to appear at this address. In this address, I'm going to enter the data value FF. Now we are ready to load our program. So let's start by going back into address mode by pressing AD and entering the starting address of our program, which will be 0200. Now let's go back into data mode and enter our program one step at a time. First, we will enter A5, which is the opcode for LDA or load accumulator. Then we will hit the plus key to advance to the next instruction and put 10 there, which is where we want to memory address that we will be using to exchange data from. Press plus again and enter A6, which is LDX, load the X register. Hit plus again and enter the memory address location 11. Next, we will enter 85, which is STA or store accumulator, and we want to store that at address 11. Then we're going to enter 86, which is STX or store the X register, and point that to address 10. Then we will end the program with a simple 00 or break command or instruction. Now, with the SST switch to the left or off, we have to actually go back into address mode and go to 0200, the starting point of our program, and then we can press go. Okay, now we can look at memory address 0010 and see we now have FF there, and if we advance by 1 we can see memory address 0011 actually has 00 in it, so our program works. Now that we have seen that our program is actually working, let's slow it down and take a look at it one step at a time. Using single step mode by moving the SST switch to the right or on position. First, let's put some new data back into address 0010 and 0011. So we'll go to address 0010 where we have FF. What should we put there? How about 11. And then for address 11, we'll put, let's say, 99. Okay, then we'll go back to address mode and go to the beginning of our program and step through our program one step at a time. Now press go and see what happens. You can see it only advanced to address 202. So the program executed the first instruction, which was LDA 10, and it should now have loaded the new value that we placed in address 0010 into the accumulator. So let's take a look at the data that we currently have in the various memory registers of the 6502 CPU. We can do that because the KIM-1 monitor program makes a copy of those registers and places them in memory so that we can view and edit those values. So go back into address mode and select address 00F3, which is the address that the KIM-1 uses to display the contents of the A or accumulator register. Here we can see the new value that we placed at address 0010. Now to get back to our program, we can simply press PC, which is for program counter key, and you can see it takes us right back to our program. Now, if we press go again, the KIM-1 will execute the next command or opcode in our program. which is LDX11. So our X register should now contain the new value that we stored at address 0011. Again, we can take a look at the contents of the registers by going to address 00F3. First, we can see the A register, then we advance twice to get to 00F5 to see the X register. So this is the A register, this is actually the Y register, and this is the X register where we have our 99. We should see the new value that we loaded into address 0011. Again, we will now press PC to go back into our program where we just left off. When we press go again, it will advance through the next step of our program, which is STA11, where we will store the contents of the A register into address 0011. Now we will go ahead and single step through the final opcode, STX10, which will copy the contents of the X register into memory location 10. So now when we look at the memory addresses at 0010, it now contains a new value that we had placed in the memory address 0011, and the memory address 011 now contains the value that we had set up in memory address 0010. There's our 99 and our 11. Like I said, this first mini program did not teach us a lot about programming in assembly language, as it only had 5 instructions in total: LDA, LDX, STA, and STX, and finally BRK. We did, however, learn how to set our NMI and IRQ memory vectors. We also learned how to go to specific memory addresses and enter data. Furthermore, we learned how to enter a program and execute it in normal, as well as how to execute it one step at a time or in single step mode. We also learned how to view the internal registers of the 6502 processor by accessing memory address 00F3 to 00F5. Then we learned how to simply go back into our program by pressing PC or program counter key so that we can continue executing our program where we left off. So you see, this first mini program really taught us a lot. So that's it for now. Thank you for watching and supporting this channel, The Age of Gaming.